fire safety handout we gave you. This is about braking strength. All right, so this first problem here, braking strength of shipboard tackle system is roughly 3,000 pounds, and you want to maintain a safety factor of 8. What will be your safe working load in pounds? Okay, well, you have a formula sheet, okay, and there's a basic formula here that we're going to use, is that braking strength equals the safe working load, all right, and that's times the safety factor, okay? But in this problem here, we want to get safe working load. So we've got to solve for safe working load, okay? We got to get it all by itself. So to do that, what I'm going to do is I'm going to divide this side by safety factor and this side by safety factor, and that cancels out there. So when we rearrange this, it's safe working load equals braking strength divided by safety factor. That's our formula. So I'm going to just bring that up here. Safe working load equals, what's our braking strength? Oh, well, looks like it's 3,000 pounds. And our safety factor is 8. So when I divide those out, I should get 375 pounds. Okay? So that's the answer to the first problem. All right. So let's do the second problem. Let's look at it. Derrick mounted on a barge has an estimated braking strength of 6 tons. You wish to operate a safety factor of 10. What is your safe working in pounds? Okay, so we're going to use the same basic formula, but you got to see here that there's going to be a conversion from tons to pounds. All right, so we're going to need 2 formulas. All right, we're going to need that braking strength is safe working load times safety factor. And I'm going to solve it for safe working load, so I'm going to divide by safety factor again. And that's going to cancel out. So safe working load is braking strength divided by safety factor. And then I'm going to need a conversion, okay? And so the conversion factor I'm going to need later is that 1 long ton equals 2,240 pounds, okay? So I'm going to need that in just a little bit too. So let's first solve here. Our safe working load is going to be our braking strength, which in this case is 6 tons, divided by 10, okay? And so that is 0.6 tons, okay? Now what I got to do is I got to convert tons to pounds. So I know that 1 long ton or a ton is 2,240 pounds. I'm going to need a conversion factor. I'm going to need to have I need tons to cancel out, okay? So I'm going to need, in my conversion factor, for tons to be in the denominator, okay, so that they cancel out. And then that means that pounds would be in, and the number of pounds would be in the numerator. Okay, so that cancels out. So I got 0.6 times 2240, okay, and that is 1,344 pounds, okay? That is going to be the safe working load in pounds. That was it in tons, and I converted it to pounds. Okay, so that's problem 2. All right, let's take a look here at problem 3 here. Okay, all right, you intend to lift a steel gangway weighing 650 pounds. So, okay, so maintaining a safety factor of 6, what will be the braking strength of the lifting gear needed? So we're going to use 650 pounds as our safe working load here, okay? So braking strength is safe working load, okay, times safety factor. Well, so we're going to end up inserting that into there, okay? So let's see, braking strength in this case is going to equal 650 pounds, okay, times a safety factor of 6, and that equals 3,900 pounds braking strength, okay? But they want the answer not in pounds, but in tons. So now I have to convert again. So this time, what I need is I need to have pounds in the denominator. I'm going to multiply it by a conversion factor. So I have pounds here, I got to have pounds below so that they cancel out. And that means how many pounds was that? Well, that was 2,000, before I cancel that out, there's 2,240 pounds per 1 ton. So the pounds are going to cancel out, the number still stays. So I'm going to take 3,900 divided by 2240, and the units will be tons at the final answer. And that's 1.74 ton. That's the breaking strength. Okay, I would need a wire that had a 1.74 ton breaking strength in order to maintain a safety factor of 6. Okay, so now we're going to do this problem. We want to lift a pallet of lube oil weighing 0.9 tons and maintain a safety factor of 7. What will be the breaking strength of the gear needed? All right, well, we're going to use that same formula. Breaking strength is safe working load times safety factor. Now look, you see me writing this formula over again and again and again. I think you should do the same thing. Every time you write the formula, it's going to help you sort of remember it. You're going to have to memorize these formulas eventually for the Coast Guard exam. For the exams in seamanship, we'll give them to you, but I think it's worth writing them down each time. Okay? So, what's our breaking strength? Well, we're 0.9 tons, 0.9 tons. And our safety factor is 7. So that is 6.3 tons. Okay? Okay, that one's good. Okay, in this problem, problem 5, you are working a tackle system with an estimated breaking strength of 1,800 pounds. If you are lifting drums weighing 240 pounds one at a time, what will be your safety factor? All right, well, let's go back to our original formula. Breaking strength is safe working load times safety factor. Well, in this case, we want the answer to be safety factor, so we got to isolate this. So what are we going to do? If we divide this side by safe working load, that's going to cancel out. But there's an equal sign there, so I got to do safe working load over here too. So my new formula is going to be safety factor is breaking strength divided by safe working load. Okay, so let's now substitute some of these numbers in here. What's the breaking strength from the problem? It's 1,800 pounds. And what is my my safe working load? Well, my working load is 240 pounds. Okay, look at that. Pounds and pounds cancel out, and safety factor has no units. So that's a good indicator to me that I set this up properly. 7.5 is the safety factor. Okay, all right, good. All right, let's move on to problem 6. All right, so problem 6. You are operating a small shipyard crane with a breaking strength of 3.4 tons. Okay. If you are lifting pallets aboard that weigh in the vicinity of 1,000 pounds per piece, what will be your safety factor? Well, what's our formula? Breaking strength is safe working load times safety factor. Okay. So we want to find the safety factor, so I'm going to solve for safety factor. Safe working load. That cancels out. Safety factor is breaking strength divided by safe working load. Okay? So you can see that I'm deriving my new formula every time. I think you should do the same thing. Okay? So now let's solve this. Well, so safety factor is going to be 3.4 tons divided by our safe working load, which in this case is 1,000 pounds. Okay, now if you get to this point, you should recognize, oh, you know what? I got tons, I got pounds. Oh, geez. Okay, I got to get rid of both of those. Okay, safety factor has no units. I got to get rid of the tons. I got to get rid of the pounds. Oh, how am I going to do that? I'm going to multiply by 2240 pounds. Oh, look at that. Divided by 1 ton. Oh, and that's going to make all those units go away. And when I do out my math, now I should get 7.62 is my safety factor. Problem 7. Okay? So, let's go ahead and do that. Okay? All right. Here we are with problem 7. Great. So, let me take a look at this. All right. So while performing maintenance at sea, you notice a nice spool of 1-inch diameter rope, and it's 6 by 19, lashed to a stanchion. Chief mate later asks you what the breaking strength and safe working load of this wire is. first thing we want to notice here is that, they tell us it's 6 by 19, but that information is really irrelevant. What's important is that it's wire and it's 1 inch diameter. Breaking strength of wire is going to be determined by the diameter, okay? So we need a new formula. So if you go back to your formula sheet here, okay, it's right here. It said that breaking strength, okay, for wire rope, breaking strength is 2.5 times c squared, okay, and that's going to give us our answer in long tons, and the c squared has got to be in inches, okay? So let's come back over here. So we're going to need this formula here, all right? We're going to need a formula. Breaking strength equals c squared times 2.5, okay? We're also going to need our formula. Breaking strength is safe working load, okay, times safety factor. We're going to use that one as well. But we need one more formula, okay? Because this formula is in circumference, but they gave us this diameter thing. So we come over here, and we need the circumference is pi times diameter. So I'm going to need that formula as well. C equals pi d. All right? So we're going to use all three of these formulas. And in fact, I think what I'm going to do here is I'm going to go ahead and I'm going to solve using this one first. All right? And then I'm going to do this one next. And then I'm going to do this one last. I'm going to solve for my safe working load at the end. Okay, but I'm going to start with my circumference. Then I'm going to solve for that. I'm going to stick it into this formula here. That's going to give me breaking strength. And then I'll stick breaking strength into here, and I'll solve for safe working load before I do that. So let's go ahead and start that. Okay, so step 1, C equals pi d. Well, what is our C? Well, 3.14, that's pi. That's all you need to know. You don't need to go on. We don't need the 1/6. Okay, 3.14 is plenty. And our diameter here is 1 inch. So C is 1 times 3.14. It's 3.14 inches. Okay, so that's good. We did that step. Now what we're going to do is we're going to substitute 3.14 inches in for C squared. So let's do that now. Okay. Breaking strength is c squared times 2.5. Okay, so what's our c? Is 3.14. So breaking strength is 3.14 squared times 2.5. And when you do that out, that should come out to 5,013. Excuse me. That should come out to 24.6 tons. Okay? All right, because that formula gave you tons. Okay, great. All right, great. So that's one of the answers. Okay? All right, that's one of the answers right there. Breaking strength is 24.6 tons. But the chief mate also wanted to know what the safe working load was. Well, so now we got to do that, step 3. Breaking strength is safe working load times the safety factor. Okay, but we want to solve for safe working load, so I'm going to divide both sides by safety factor. And safe working load is breaking strength divided by safety factor. My breaking strength is 24.6 tons, and my safety factor here, now they didn't give us one. So if they don't give you one, the standard that you're going to use for wire is a safety factor of 6. Okay? So I'm going to take 24.6, divide that by 6, and my answer is going to end up being 4.1 tons. Okay? That equals 4.1 tons safe working load. Okay? All right. That was quite a few little steps there. All right. So the next two problems are going to be even more steps. Okay? So in this one, a new coil of 3/4 inch diameter manila comes on board. What is the breaking strength of this line in pounds? Okay, great. All right, well, I know that, oh, look, they've given me a diameter. All right, I know I'm going to need the formula C equals pi d. I know I'm going to need that formula. Okay? Now, I need to know the breaking strength for Manila. Let's go back to our formula sheets, and I want it to be in pounds. So here you go, natural fiber. Manila's natural fiber. You're pretty much not going to be using, that natural fiber means Manila. You're not really going to be using any of the other natural fibers in too many applications on a ship. And you probably won't even be using Manila, all right? But anyway, if you were using Manila, you've got two formulas here. Breaking strength is C squared divided by 2.5. Oh, that's for problems in long tons. Breaking strength is 900 divided by C squared. Oh, that's for problems in pounds. Oh, they want it in pounds. So I need this formula. Breaking strength is 900 times C squared. So I'm going to use that formula too. Breaking strength is 900 times C squared. Okay? Now, at the end of the day, though, I also need safe working load. So I'm going to need this formula, my old tried and true. Breaking strength is safe working load times safety factor. Okay? And, yeah, okay. So I'm going to have to rearrange that one at some point as well. So let's do step one. C equals pi d. C equals 3.14. Now my diameter is 3/4 of an inch. So I know that that's 0.75 inches, but if you don't, take 3 divided by 4, you'll get 0.75. So C is going to be 2.36 inches. I've done step one. Now I'm going to do step two. Breaking strength is 900 times C squared. Okay? Well, let's see here. Breaking strength. Now I'm going to substitute 2.36 in for C squared, or in for C and square it. So that is 900 times 2.36, and I got to square that. So take 2.36, square it, multiply it by 900, and you're going to get a breaking strength equal to 5,013 pounds. Okay? So we've done step two. Now we're going to do step three. Okay? Breaking strength is safe working load times safety factor. In this case, I want to, what will be your safe working load? So I got to get safe working load by itself. So safe working load is breaking strength over safety factor. Now I can substitute in. Okay? My breaking strength is 5,013 pounds. And my safety factor is 5. So when I take 5,013 and I divide it by 5, I get 1,002.5 pounds. Okay? And that will be the answer for the safety factor, and this is the answer for the breaking strength. Okay? All right, now we're going to do problem 9. This problem is the most complicated problem. Okay? Let's read it here. So we got a new coil of 1.5 inch diameter polyester. Polyester line has just come on board. What is the breaking strength in tons? And what will be your safe working load in pounds? Oh my gosh, I got tons, pounds. I'm going to need to do my conversion for that. Oh boy. Oh, they give it to me in inch. So I'm going to need several formulas here. 1, C equals pi d. Okay? C equals pi d. But now it's polyester. So let's go to our formula sheet here. And let's look for polyester. Oh, for natural fiber rope. Well, polyester is a synthetic. It's not a natural fiber rope. So, let's keep reading. For nylon and polyester, use the fiber formulas and multiply by 2.5. Well, that makes sense. Nylon and polyester are stronger than manila. They're 2.5 times stronger in general. So if I use that formula for manila and then I multiplied it by 2.5, that would be the breaking strength for these. Polypropylene, though, is not quite as strong. It's stronger than manila, but it's not as strong as these. Look at that. You're going to multiply it by 1.5. So what I need is, what am I using? I'm using polyester. So polyester, I'm going to need this 2.5. Okay, so, and what am I doing this problem in? I'm doing this problem in, I need my breaking strength in tons, okay? So breaking strength in tons is this formula. So I'm going to use that formula, 2. Breaking strength is, is circumference squared divided by 2.5. Okay? And then I'm going to need another formula. Breaking strength of poly is breaking strength of natural or manila times 2.5. Okay, I just made that formula up just by taking this sentence and turning it into a formula. Okay? And then I need my old tried and true. Breaking strength is safe working load times safety factor. And I know I'm going to have to mess around between pounds and tons again. So 1 ton, that's a long ton, by the way, is 2240 pounds. Okay, we've got quite a few little steps to do. Let's do them. 1. C equals pi d. Well, that's 3.14, and the diameter is 1.5 inches. Okay? All right, so when I do that, I get C equals 4.71 inches. Okay? 4.71 inches. Okay, now I'm going to do step 2. Breaking strength is C squared over 2.5. Okay, well, breaking strength is going to equal the circumference squared, 4.71 squared over 2.5. Breaking strength is going to equal 4.71 squared in your calculator divided by 2.5, and that should come out to 8.87 tons. Okay? Now we're going to do step 3. It's 8.87 tons for natural fiber rope, but we're not using natural fiber rope. We're using poly. Poly is 2.5 times as strong as polyester. So I'm going to multiply this by 2.25. But here's my little sort of formula I made up. Breaking strength of poly is breaking strength of manila times 2.5. So breaking strength of poly is 8.87 tons times 2.5. And that gives me my breaking strength of poly. That's going to be 22.2 tons. Okay. Now, I got to find my safe working load. So 4, breaking strength is safe working load times safety factor. Well, I want to solve for safe working load, so I'm going to divide both sides by safety factor. And I get my safe working load is going to equal breaking strength divided by safety factor. Okay, well, let's do that. That is, my breaking strength is 22.2 tons divided by my safety factor of 5. And when I do that, I'll get, what do I get there? I get 4.4 tons. Okay? So now I've got my answer for safe working load in tons, but I want it in pounds. So I got one more step to go. Come up here. Step 5. I've got 4.4 tons times, okay, now I need to multiply by a conversion factor. All right. Tons, I got to have tons down here. So I got to have 2240 pounds up here. So 4.4 times 2240, and that ends up being a safe working load equals 9946 pounds. And that is the end of the problem. What was our breaking strength in tons? Breaking strength in tons, and there was our breaking strength in tons. Okay.